Hey everyone, welcome back. This one's going to be another kind of a different one coming to you from the top of Mount Princeton. So I'm going to real quickly, with respect for everybody else up here, I'm going to try and tuck myself a little bit away from the other people up here, but let me real quick turn the camera around, just kind of give you a view of what we're seeing here, because this view from up here is just absolutely amazing. So Princeton's not the highest one here. We were going to try for Elbert, which is the second highest peak in the continental US. That would have been fun, but it's way up over there. We had some kind of time constraints, but this one's worked out pretty well. We're summiting probably as late as we probably should. So if we tried the much longer hike on Elbert, would have been a lot. So we're only at about 14,100 and some change, but still a little out of breath. So you may get a short video today, but this hike's been a lot of fun. But figured today I'd talk about field-effect transistors, because it seemed like a natural step from the bipolar junction transistors. Step back, you remember from capacitors. Now, the idea of a capacitor is you apply voltage on one side of an insulative material, and it builds up an electrostatic charge on the other side, preventing current from flowing once that field is built. Well, if we did the same thing, imagine a wire with a little bit of semiconductor along that wire, but then another wire coming into that from the side. So we give a three-terminal device, much like the bipolar transistor. Now, instead of the bipolar transistor, which is really just two diodes that need to be forward biased, the field effect transistor gives us a gate, that's the control side coming in, but then we separate it with that insulative material, much like a capacitor. And if you remember again to capacitors, there's no current actually going through a capacitor. It's just the voltage on one side influences how much current is traveling on the other side of that insulative barrier. Now, if we apply that insulative barrier to the gate, we can apply a voltage to the gate or the control side, and no current actually flows through it, or at least a very, very minimal amount. Then, as you apply voltage, it applies an electrostatic field, which causes a channel of semiconductor on the main current traveling side to either be closed off or opened up. Now, there's different variations of field effect transistors. Probably one of the most common ones that you'll run into is where we have a metal plate, kind of like the capacitor, and then an insulative silicon dioxide, which is glass, insulative layer, and then you have your semiconductor material. Now, since they use an electrostatic field to turn on and off, we call them a field effect transistor. The metal oxide semiconductor construction, we use the acronym for that one, MOS, Field Effect Transistor, FET, and you've probably seen the acronym MOSFET on like higher end audio amplifiers, things like that. MOSFET, so a metal oxide semiconductor, we apply a voltage, usually no more than like 4 or 5 volts, to the gate, which is attached to that metal plate, and then it influences the amount of current allowed through the channel on the main current handling side. Now, sometimes these field effect transistors can have a very low resistance on the current traveling side or the load side. They call those terminals the source and drain. So the current allowed through the source to drain can be extremely high because of very low resistance. So if it has a low resistance, we don't really build up much voltage. Therefore, there's not a whole lot of power dissipated. So we end up having a very low amount of energy loss, which allows us to use much more current. But then we look at the gate side, the control side. Since very little current is actually flowing, we just apply a voltage, and we really haven't asked that much from our control system, like a microcontroller or something like that. So we can get many more field effect transistors into a control circuit than we would bipolar junction transistors. Because although the junction transistors use low current, it's still a whole lot more than the field effect transistors. Also, when you have to turn on a field effect transistor, since there's very little current, it doesn't take nearly as much time. So if we need a very high frequency switching operation, then we'd probably be more likely turning to the field effect transistor than the bipolar junction transistor. The main disadvantage of the field effect transistors is in that time between being turned completely off and completely on, there's not a whole lot of control most of the time. Bipolar junction transistors afford you a lot more control during that transitional period. in between completely turned off and completely turned on. But very often the field effect transistors are used as a high frequency switch for a lot of current. Now, we also have variations that when I said the channel allows current to flow or not, that channel can be built out of either a negatively charged or a positively charged material. So it has either a P channel or an N channel semiconductor material. So you have an N channel MOSFET or a P channel MOSFET. And I'll go into more length on later videos because there's a whole lot more to them. You have some variations called enhancement versus depletion mode. And actually the symbol diagrams give you a little bit of an idea of how you can identify which one you're dealing with. There's also other types of the field effect transistors that don't have that metal oxide semiconductor construction. So there are field effect transistors or junction field effect transistors, JFETs, but probably more commonly we see the MOSFET, and with the different variations it's kind of complicated to figure out exactly how to control those, but once you get the handle on it, they're incredibly useful devices to get a handle on. So thanks for watching. Hope you enjoy the view as much as I did. It's been pretty fun to record these videos, these pretty cool locations, and hopefully I'll choose a few more here, but this one's been a lot of fun. And so now I need to go catch my breath and then begin the travel back down. So have a great day, and check out more videos as we keep uploading them. Thanks. Bye.